All right, let's get started with 6.5, trig functions of non-acute angles. Okay, so as we saw last time, instead of saying SOHCAHTOA, we can replace opposite with the y value, because if we make a triangle starting from the origin, the opposite side is always going to be the y, and then we can replace the adjacent with the x value. And then the hypotenuse will be the radius of the circle that would be inscribed if we swung that hypotenuse around the origin. We have the radius there. Okay, one thing to keep in mind here is that if you're in quadrant 1, x, y, and r are always positive. In fact, r is always positive. But if we go to some other quadrants, like if we go to the left, then x would be negative. And if we go down below in quadrants 3 and 4, then y is going to be negative. And there's a handy little shortcut for that. ASTC, all students take calculus. This is the one where if you say A, that means that all of sine, cosine, and tangent are going to be positive if you're in quadrant 1. If you move to quadrant 2, then only sine is positive. If you move to quadrant 3, then only tangent is positive. And if you move to quadrant 4, then only cosine is positive. The others are going to be negative. All right, let's see what we've got going here. Let's find sine if we know something about cosine. So this says cosine of theta is negative 3 over 5, and the terminal side of theta lies in quadrant 3. So we're going to go out into quadrant 3. We'll make ourselves our triangle like we've been doing. Theta is on the interior angle. And cosine, if you remember, is your x value over the r value. So we're going to say negative 3, and r is always positive. So if you're wondering which one's the negative, it has to be the x value since we're going to the left. All right, we'll use the Pythagorean formula. This is going to be negative 4 here. So if we find sine, then we're going to say sine theta is the y value, negative 4, over the r value. So sine theta is negative 4 over 5 if you're in quadrant 3. Okay, your turn. Give it a shot. So this says we are in quadrant 3 again. Down we go. And we say that sine theta is negative 3, the y value, over 4. And so then with Pythagorean theorem, 4 squared equals 3 squared plus the x squared value. So this is going to be 7 equals x squared. And so this would be negative the square root of 7. And so let's find cosine. Cosine will be negative rad 7 over 4. Okay, let's talk about some quadrantal angles. Quadrantal angles are just the ones that lie on the axes. So we could say 0 degrees, we could say 90 degrees, 180, so on and so forth. So let's see what happens here. Cosine of 540. So where is 540 anyway? Let's subtract 360. And so 4 minus 6, you're going to get 8. 1, so 180 degrees. So 540 is the same as 180, which is right here. Okay. All right, so what could be some values right there? We could say that this is negative 1, 0. And your r is going to be 1. This is 1 unit away from the origin. So what's the cosine at that point? Cosine is the x value over the r value. In this case, negative 1 over 1. So the cosine of 540 turns into negative 1. What about the sine of 270? Where's 270? 270 is right here. This could be 0, negative 1. And sine is y over r. The r here is also 1. So this is going to be negative 1 over 1. And so that's also negative 1. So what's negative 1 plus negative 1? The answer is negative 2. Let's talk about this one. Cotangent of 90 degrees. 90 degrees right here. So this is going to be 0, 1 with an r of 1. Remember that cotangent is going to be x over y. And so if we look at the x value, we get 0. We look at the y value, we get 1. 0 over 1 is a value of 0. And what's the tangent of negative 90? Negative 90 is down here. So this would be 0, negative 1. And the tangent value is y over x. In this case, the y value, negative 1, x value 0. That's undefined. 0 plus undefined is undefined. So the answer to B would be undefined. All right, see if you can work this out for these two problems. All right, for the first one, 90 degrees is right here. So that's going to be 0, 1 with an R of 1. And cosecant is the flip of sine. So this is going to be R over Y. And secant of 180. 180 is over here. This would be 0, -1 with an R of 1. And secant is the flip of cosine. Cosine is R over X. So at 90 degrees, our R is 1 and our Y is 1. At 180 degrees, the R is 1 and the X is, sorry, I flipped this. This is -1, 0. The X is -1. So we would have 1 plus -1, and we would get 0. All right, what about 630 degrees? So let's go ahead and add 720, 2 full circles onto this one, and we get 90 degrees. And then we'll do the same thing here. If we add 720, we get 90 degrees. So we're doing the cosecant and the secant at 90 degrees. So at 90 degrees, we've got 0, 1 with an R of 1. So cosecant is going to be the flip of sine, R over Y, plus secant, R over X. And so in this case, we're going to have 1 over 1 plus 1 over 0. It's undefined because of the 1 over 0. Okay, let's determine whether a value is within the range of a trig function or not. So this one, we just need to think about what our values are. So this is saying that the cosine, which we know the cosine is going to be the x value over the r value, or you could think about it as the adjacent side over the hypotenuse. Either way you want to think about it, is equal to 1.001 over 1. We could always put it over 1. Now, can the hypotenuse be the shorter side? The answer here is no. The hypotenuse has to be the bigger side, so this is not possible. Let's talk about B. So cotangent is going to be the x value over the y value. That's 0 over 1. Is it possible to have an x of 0 and a y of 1? Sure. How about right here? So this could be 90 degrees. So this is absolutely possible. And for our last one, secant theta is rad 3 over 2. If we remember that secant is our r over, this is the flip of cosine, so it's going to be r over x. Could we have rad 3 over 2? The square root of 4 is equal to 2. Remember that the hypotenuse, the radius, has to be the biggest side, so this needs to be bigger than 2, so this would not be possible. Okay, just a small thing. We're not going to spend too much time on it, so I'll go ahead and skip this one. We can talk about that in class. Not too worried about that last one. What we are worried about are reference angles. So reference angles are the angles made inside of the triangle that you draw. That's the important thing. Okay, so if we draw ourselves a triangle, then the reference angle is the angle on the inside. So if this is our angle, the reference angle is the angle inside. If this is our angle, then the reference angle, after we draw our triangle, is the angle inside. Okay, same thing here. If we spin all the way around into quadrant 4, the reference angle is the angle inside. Okay, and so let's see how this works. So find the reference angle for each angle given. So 210 would mean we spin all the way into quadrant 3. We have spun 180 degrees to get over to here. So what's left over? 30 degrees is left over inside the triangle, so 30 degrees is our reference angle. What about 135? 135, we spin into quadrant 2. We've got 90 degrees to get up to here. We went another 45 degrees into here. So what's left over in here? 45 degrees. The angle inside the triangle is 45 degrees. 422, we're going to spin around 360 degrees. And what are we left with? We're left with 62 degrees, which is in quadrant 1. So that would be the angle on the inside. Our reference angle here is 62 degrees. See if you can do it. All right, 160, we spin into quadrant 2. We've got 90, plus we've got another 70. So what's left over? 20 degrees. So 20 degrees is your reference angle for A. 285, there's 90, 180, 270, plus another 15 out here. So what's left over in here? 75 degrees is your reference angle. And 600, let's take away 360. We get 240 degrees. So 240, 90, 180, 240. 60 is what's left over in here, 240 minus the 180. So 60 degrees would be your reference angle on part C. Okay, so let's go ahead and use that. So cosine of 210, 90, 180, 210 has a reference angle of 30 degrees. Okay, I don't know off the top of my head what the cosine of 210 is, but I do know the cosine of 30 degrees. It's on our table of values that we know. The cosine of 30 degrees is rad 3 over 2. Let's think back to our positivity table. All students take calculus. In quadrant 3, tangent is the only thing that's positive. So if the cosine of 30 is rad 3 over 2, cosine of 210 will have the exact same value. But since we're in quadrant 3, it will be a negative because tangent is the only thing that would be positive in quadrant 3. Okay, your turn. Give it a shot. Sine of 330. All right, first step, find your reference angle. So around we go. That'd be 30 degrees right here. So we're going to do the sine of 30 degrees. It's equal to 1/2. All students take calculus. Cosine is the only thing that would be positive here. So if the sine of 30 is 1/2, the sine of 330 is negative 1/2. Okay, let's do another example here. Tangent of 495. So let's take away 360. And so we'll be dealing with the tangent of 135. 135 is right here with a reference angle of 180 minus 135 is 45 degrees. What's the tangent of 45 degrees? From our table, we know that that is 1. Okay? So all students, sine is the only thing positive there. So the tangent of 495 is negative 1. Your turn. 660, so take away 360. We end up with 300. Around we go. We're left with 60 degrees in here. The tangent of 60 degrees from our table is rad 3. All students take calculus. It's going to be negative because cosine is the only thing positive there. So the tangent of 660 is negative rad 3. All right, let's try one more. Let's go negative with this. So negative 210. I like to just get rid of the negatives right away. So let's add 360 to that. 360 minus 210 is 150 degrees. 150 is 90 plus 60. So that means there would be 30 degrees left over in here. So the cosecant of 30 degrees, I don't know what the cosecant of 30 is off the top of my head, but I do know that the sine of 30 is 1/2. So the cosecant of 30 must be 2, the reciprocal of that. So the cosecant of negative 210 degrees, all students, sine is positive, so is cosecant when we flip it over, is 2. Your turn. All right, go ahead and add 360. That just gets you to 30. So we're doing 30 degrees. That one's fairly straightforward. The secant of 30 is the flip of the cosine of 30. The cosine of 30 degrees is rad 3 over 2. So if we flip that over, we get 2 over rad 3. Let's rationalize that, rad 3 and rad 3. So we would get 2 rad 3 over 3. And in quadrant 1, everything is positive. Our answer is 2 rad 3 over 3. Okay, let's find the exact angle measures given trig function values. So let's find all the values of theta where sine is negative rad 3 over 2. Okay, so sine is going to be negative in quadrants 3, and quadrants 4, right? Because it's going to be a negative value. If we go to our trig table, the value table, sine of theta equals rad 3 over 2 when theta is 60 degrees. Okay? So if we go in here and have a reference angle of 60 degrees, we add the whole angle here, 180 plus 60 is going to be 240 degrees. So theta equals 240 is one possible value where we're going to have a negative rad 3 over 2. The other one here, 60 degrees in here, if we took 60 away from 360, the other option is 300 degrees. Okay, so those are our two possible answers, but we could keep spinning around as many times as we wanted and end up back in here. So we need to say plus or minus 360 n, plus or minus 360 n, meaning that we can spin around plus or minus as many circles as we want and end up right back at those two spots. So 240 and 300 degrees, plus or minus full circles. All right, your turn. All right, where is cosine equal to negative 3? Where's cosine on your table equal to rad 3 over 2? Theta, if you look at your table, is going to be 30 degrees when you get rad 3 over 2. So let's think about the negative now. Cosine is negative over here in quadrants 2 and quadrants 3. So we would have 30 degrees in here and 30 degrees in here. All right, so what angle is this? This would be 180 minus 30, so 150 degrees. And this would be 180 plus 30, so this is 210 degrees. Plus or minus 360 n, where n is any number of rotations. Okay, last one, we're going to plug these into the calculator, so I'm going to skip that. You guys know how to use your calculator, and we'll move on to the next one here. Find the measure of theta rounded to the nearest degree if sine theta equals negative 0.6293, and the terminal side is in quadrant 3. So we know we're over here in quadrant 3. Okay, so let's figure out what theta is. So theta equals the inverse sine of negative 0.6293. All right, so let me grab my calculator. So inverse sine of negative, make sure you use the negative, not the minus, 0.6293. Hit enter. And we get negative 38.99, so let's round that up to negative 39 degrees. So we're going to say that theta is negative 39 degrees. Okay, so how is that possibly going to work here? So if we go rotate down 39 degrees, that's what we're dealing with. So what would that be if we said between 0 and 360? So let's just go the other way. What's 360 minus 39? And so the answer to that for this angle all the way around here is going to be 321 degrees. That's one answer. But we could also be over here. So what is this answer? If the reference angle is 39 degrees, we're going to say 180 to get to here plus 39. It's going to be 219 degrees. Okay? So those are the possible measures of both of those. All right, so give this a shot real quick, and that will do it for this section. Oh, you know what? I apologize. They told us we had to be in quadrant 3, so it's not that one. It's just that answer. All right, so last one here, quadrant 2 up here. And let's go to our calculator. We're going to say second cosine of negative 5299. (122 degrees). So that's saying this is 122 degrees. Okay, find the smallest possible angle. That's the smallest possible angle in quadrant 2. So that is our answer, 122 degrees. All right, you've done it. There's a lot going on in this section. If not everything made sense, don't worry. We'll go over it all in class, and we will see you in class. All right.